Today's lesson is on proofs with parallel lines and transversals. So, first I'm going to give you some postulates and theorems that we're going to be using in our proofs. A postulate is a statement which is taken to be true without proof, and a theorem is a statement that has been proved to be true. So we don't have to prove these things, we can use them in our proofs. So, the corresponding angles postulate says if two parallel lines are cut by a transversal, then corresponding angles are congruent. So we talked about that yesterday. Here I'm just putting it in a formal way and telling you that that is called the corresponding angles postulate. So again, they have to be parallel, but if you have two parallel lines, then the corresponding angles are congruent. So these two angles, and there's several pairs of corresponding angles. This one, those are sets of congruent angles. The alternate interior angles theorem says that if you have two parallel lines cut by a transversal, then alternate interior angles are congruent. So here's your alternate interior angles, and they are congruent. The consecutive interior angles theorem says if two parallel lines are cut by a transversal, then consecutive interior angles are supplementary. Remember that consecutive interior angles is the same thing as same side interior. So here's your one set of same side interior, and they are supplementary. So their sum is 180 degrees. The alternate exterior angles theorem, if two parallel lines are cut by a transversal, then alternate exterior angles are congruent. So here's your one set of alternate exterior angles are congruent. You also have the converse of the corresponding angles postulate. The converse also almost refers to the postulate backwards in reverse order. That is not always true, but in this case it is. So if you have two lines, we don't know if they're parallel at this point, we're just saying if two lines, parallel or not, are cut by a transversal, but such that we know their corresponding angles are congruent, then we can say the lines are parallel. So if you know that the corresponding angles are congruent. So if you saw that this was 110 and this was 110, then you could automatically say that these lines are parallel, even if those arrows weren't there. You could say that these were parallel. The converse of the alternate interior angles theorem says if two lines are cut by a transversal and that the alternate interior angles are congruent. So if you know the alternate interior angles are congruent, then you know the lines are parallel. Converse of the consecutive interior angles theorem, if two lines are cut by a transversal such that consecutive interior angles are supplementary, again, adding up to 180, then the lines are parallel. And the converse of the alternate exterior angles theorem, if two lines are cut by a transversal such that the alternate exterior angles are congruent, then you know the lines are parallel. All right, so let's do some actual examples. So here's an example of a test question. If you know that angles 2 and 3 are congruent, so here's angle 2, here's angle 3. So if they tell you those are congruent, can you say that lines L and M are parallel? So think about that for a minute. Pause the video. The answer to that is no. 2 and 3 are not corresponding angles, they're not alternate interior, they're not consecutive interior, they're not alternate exterior. So these are our parallel postulates and theorems. 2 and 3 are vertical angles. Angles 2 and angle 3 are vertical angles and are congruent regardless of line L being parallel to line M. 2 and 3 are vertical angles. Even if I draw something that looks like this, clearly lines L and M are not parallel. but it is still true that vertical angles are congruent. These vertical angles are only on line L. It has nothing to do with line M. Okay, let's go to another example. What if I say angles 1 and 5 are congruent? Can we say lines L and M are parallel? So this time we're doing 1 and 5. We're saying 1 and 5 are congruent. If we know those are congruent, can we say lines L and M are parallel? Yes. 1 and 5 are what type of angles? Corresponding is correct. So angles 1 and angle 5 are corresponding. So if we know that the corresponding angles are congruent, then we know the lines are parallel. That's the converse of the corresponding angles postulate. So that is the converse of the corresponding angles postulate. And you do not have to memorize these. All right. If angles 3 and 5 are supplementary, can we say lines L and M are parallel? So 3 and 5, here are 3 and 5. And it's saying they are supplementary. So what type of angles are 3 and 5? 3 and 5 are consecutive interior. And if they're supplementary, yes, it means the lines are parallel. So 3 and 5 are consecutive interior angles. They are consecutive interior angles. So by the converse of the consecutive interior angles, if you know consecutive interior angles are supplementary, then you know the lines are parallel. So that is the converse of the consecutive interior angles theorem. All right, what about if angles 6 and 7 are congruent? Can we say lines L and M are parallel? So here are 6 and 7. So if 6 and 7 are congruent, does that make L and M parallel? Take a minute and think about that. The answer to that is no. Once again, 6 and 7 are vertical angles. So they are vertical angles. So it's the same reasoning as number 1. Vertical angles are always congruent, whether the lines are parallel or not. Notice that these two angles have nothing to do with line L. If angles 4 and 5 are congruent, can we say lines L and M are parallel? 4 and 5 are alternate interior angles, and they are, if they're congruent, we do know the lines are parallel. So the answer is yes. And that is the converse of the alternate interior angles theorem. All right, now we're going to do what is called a mathematical proof. In a mathematical proof, this is called a 2-column proof. You have statements and you have reasons. Today is just kind of an introduction to proofs. I'm starting you out with really easy ones. Notice there's only 2 sets of statements, 2 sets of reasons, so pretty simple. Today we'll do harder ones as the semester goes on, but today we'll do just an introduction. Your first statement is always what is given. So the information they're giving you is that the measure of angle 1 is congruent to the measure of angle 8. And you're using this diagram up here. So they're telling you that 1 is congruent to 8. Your first reason is always
we're about
given.
Ready to begin the faculty meeting in the auditorium. Please bring your red safety notebooks and your cell phones.
Your first line is very easy. It's whatever they've given you, and then for your reason you write given. Your last line, which in this case is the next line, is whatever you're trying to prove. We're trying to prove that line L is parallel to line M. And why do we know that L is parallel to M? We know that because they told us 1 and 8 are congruent, and 1 and 8 are alternate exterior angles. So the alternate exterior angle, we want the converse of it, because they gave us that the angles are congruent. That was what was given, and then we're saying the lines are parallel. So that's the converse one. So you couldn't see that. They told us that the alternate exterior angles are congruent. That's what they told us. And then we're saying the lines are parallel. So that's the converse of the alternate exterior angles theorem. Alternate exterior angles theorem. All right, for number 7, this time you're given that L is parallel to M. So that's your first statement. L is parallel to M. And your first reason is always going to be given. Then what are you trying to prove? Angle 4 and angle 6 are supplementary. So 4 and 6, we want to know why they are supplementary. Well, they told us that the lines were parallel. So this time, if we know the lines are parallel, then we know that consecutive interior angles are supplementary. So that is the consecutive interior angles theorem. Consecutive interior angles theorem. All right, last one, final exam practice. Which statement of justification would not prove that line AB is parallel to CD? So A says angle C is congruent to angle G. If corresponding angles are congruent, then the lines are parallel. So that is a true statement. C and G, if they're congruent, they're corresponding, then the lines are parallel. That's true. We're trying to find one that's not true. Angle C is congruent to angle F. C is congruent to F. Those are alternate interior angles and they are congruent, then the lines are parallel. So that's also true. D plus angle F is equal to 180. So measure of angle D plus measure of angle F, that's these two. They should add up to 180. They're supplementary. If same side interior angles are supplementary, then the lines are parallel. That's also true. D, angle A should be congruent to angle D. So here is A and D. All right. If those are congruent, if vertical angles are congruent, then the lines are parallel. That is not true. Vertical angles are congruent. That part is true. But this part is not true. Just because vertical angles are congruent does not mean the lines are parallel. A and D have nothing to do with line CD. So your answer to that one is D.